Hi guys, welcome to the next lecture. So today we will be talking about the term modular arithmetic. What is modular arithmetic? With the last video, I actually tried to touch upon with an example that I gave you about divisibility by 3. So when this concept of divisibility comes in, the concept of remainder comes in. Because it's not necessary that numbers are divisible by a particular number k every time. So modular arithmetic is that part of arithmetic that puts some emphasis on remainder. So it's the arithmetic that deals with whole numbers where numbers are replaced by their remainder after division by a fixed number. So in order to understand modular arithmetic or modulo, mod, what is important for us to understand is the concept of divisibility. So we know that if you have two numbers a and b, and a is divided by b, you can have a quotient q along with the remainder, say r. A is your dividend, b is the divisor, q is the quotient, and r stands for remainder in the terminologies that I am providing to you here. There can be times when we are just interested in the remainder. That is what is modulo or modular arithmetic all about. We use modulo or mod in that case. So, for example, when I'm saying a divided by b gives me a quotient q along with the remainder r. So I'm going to write that expression as a modulo b is equal to r. I'm focusing on the remainder. So all I'm asking is that what happens when a is divided by b? I'm not interested what is the quotient. I'm interested in, do we have a remainder? Yes, r is the remainder. So a mod b is equal to r is what we will say, and b here is referred to the modulus. Let's understand a related term here, congruence modulo. Essentially, congruence modulo means that if you have two integers a and b are congruence modulo n if and only if they have the same remainder when divided by n. Formally, what does it mean? Let's try to break this into certain definitions of modulo. So if a and b are some integers and say m is a positive integer, then a is congruence modulo, or a is congruence to b mod n. A and b are congruence modulo m, which basically means a is this symbol stands for a is congruent to. The symbol stands for congruence. A is congruent to b mod m. If and only if m divides a minus b. Now, what does it actually mean? It means that, as I mentioned, a and b have the same remainder when divided by m. It basically means that a and b have the same remainder when divided by m. What essentially it means? This would mean that when you see the difference, and this in turn would mean that a is equal to k times m plus b. And that would mean, now you can again break it. This would mean if you take b to that side, now mathematically you would understand what we're trying to say. A minus b would be equal to km, which essentially means that when you divide a minus b by m, the quotient that you get is some integer k. That means a minus b is divisible by m. Or in other words, m divides. There are times when we write it down like this. I have deliberately taken n prior to this formal definition. Here I've taken m because this is just namesake. It could be m, r, P, Q, anything. What you need to understand is that when you talk about congruence modulo, or A is congruent to B mod M or mod N, you are talking about divisibility by M or N, whatever variable has been taken up. It essentially means that A minus B would be divisible by M, or M divides A minus B. In other words, if we just talk about A, this means that when I divide A by M, I get a remainder B. So this whole thing is basically related to B, that is the remainder. For example, let's take a numeric example. 5 divides 30. We all know that 5 divides 30. So what if I make it look a little different in terms of I wanted to relate it to the definition of congruence modulo, right? So what I can say, 5 divides 50 minus 20, because 50 minus 20 is actually 30, right? So I can say 5 divides 50 minus 20. So 5 behaves like your M, and 50 minus 20 behaves like A minus B. In other words, what are we saying? We are saying 50, that is your A, is congruent to B, that is 20 mod 5. So if in terms of A, B, M, I want to look at it, I am saying A is congruent to B mod M, right? Now my question to you is 50 also congruent to 15 mod 5? Well, the answer is yes. And why can I say that? Because 50 minus 15 is definitely divisible by 5, right? Another question is 50 congruent to 10 mod 5? Absolutely yes, because again, 5 divides 50 minus 10. Similarly, 5 divides 50 minus 5 as well. So 50 must be congruent to 5 mod 5, right? So what's happening here essentially, if you notice, what is this relation? What is this relation? 50 is congruent to 15 mod 5. 50 is congruent to 10 mod 5. 50 is congruent to 5 mod 5. What is this relation? This relation that you've seen here, 50 is congruent to 15 mod 5. 50 is congruent to 10 mod 5. 50 is congruent to 5 mod 5, so on and so forth. These are called congruencies, and congruency is an equivalence relation. And this brings us to the concept of equivalence class. Now, what is an equivalence class? Like in previous example, if I think of modulo 3, in the previous example, we were thinking of modulo 5. That was basically when we were dividing by 5. Now, if we think of modulo 3, when we divide by 3, what are the possible remainders? Well, the possible remainders are, maybe you are not left out with any remainder. Maybe you are left out with remainder as 1. Maybe you are left out with remainder as 2. So whenever you are dividing by an integer, say n, the remainders that you can have could go on from 0 till n minus 1. So equivalence class is basically a name given to a subset that includes all elements that are equivalent to each other. So when in case of modulo, we are talking about an equivalence class. Say, for example, I quote bracket 0. Now, what this bracket 0 is telling, this is how we write equivalence class. This bracket 0 is telling you that you will get remainder 0 when you divide by 3, because we are talking about modulo 3. This class would consist of, this set would consist of all the integers, which when you divide by 3 will give you a remainder 0. So say, there can be many negative integers, and then say -9, -6, -3, because when you will divide by 3, you will not be left with any remainder. 0, 3, 6, 9, so on and so forth. Hence, this is the set of all integers such that all integers a such that a is congruent to 0 mod 3. Similarly, when we are dividing by 3, again, if I take this class, the equivalence class 1, when dividing by 3, the equivalence class 1 of 1 would mean that what are those integers that when you divide by 3, you will be left with remainder 1. So this will be the set of all integers like minus 10, minus 7, minus 4, minus 1, 1, 4, 7, 10. If you divide these numbers by 3, you will always be left with remainder 1. So this is the set of all a's belonging to Z such that a is congruent to 1 mod 3. That is, the remainder that you're left with is 1. Similarly, you can be left with remainder of 2 when you're dividing by 3. So the class, equivalence class 2, in case when you are dividing by 3, would be. So this would be the set of all integers minus 8, minus 5, minus 2, so on and so forth, 2, 5, 8. You can see it for yourself. When you will divide these numbers, these integers by 3, you will be left with remainder 2. So this is a set of all integers a belonging to Z, where a is congruence modulo congruent to 2 mod 3. Similarly, you can have a example. You can think of an example where you're dividing by, what are the possible remainder when you divide by 4 or mod 4? The remainders could be 0, 1, 2, and 3. Hence, the classes that you can construct: 0, you can construct the class of equivalence class of 1, equivalence class of 2, equivalence class of 3. I'm going to leave that as a homework for you. Please try this out. Now the question arises, why this concept? This actually is a concept which we frequently use in our everyday life. I'll tell you the use of this concept, the concept of remainder. It makes our life very easy. For example, say today is a Sunday. And my question to you is, what day will it be 60 days from today? Would you be like counting, day by day, what day it would actually be? Or would you be directly just saying that, oh, it should be a Sunday only, since it's just 2 months apart? No. Now, every week has 7 days, Monday through Sunday, right? In total, I have 60 days. So if I divide these 60 days in terms of weeks, I can perhaps get my answer very quickly. So what I'm going to do here is we can divide these 60 days into the bunch of 7. And as I'm going to do that, what will happen? Divide 60 by 7. 7, 8 times, if you take 7, you get 56, right? And you get a remainder of 4. So what have we just done here? So I know that if it is Sunday today, exactly 1 week after it will be a Sunday. Okay. Exactly after another week, exactly 2 weeks after it will be a Sunday. So what here just happened? Exactly after 8 weeks, you will have a Sunday. But what is happening is that I'm left with 4. I have a remainder of 4. So what is happening here? 60 is equal to 7 into 8 plus 4. That means exactly 56th day would be a Sunday, but I have to move up till the 60th day, which means that I will be adding up 4 days ahead, which means it will be a Thursday. So how will you find out if it's a Sunday today? What is day 60 days from now? It's going to be a Thursday. Let's now connect this to the definitions that we've done. So the connection would be that what we have is 60 is equal to 7 multiplied by 8 plus 4. Or in other words, 7 divides 60 minus 4? Absolutely right, because 7 divides 56, which means that I can say that 60 is congruent to 4 mod 7, or in other words, A is 60, B is 4, and mod M is 7. That is what we have done today. Okay, this is the concept of modulo. Modulo deals with the remainder, and it brings you to the concept of equivalent class, not just equivalence relation. Equivalence class is automatically an equivalence relation, or congruency is an equivalence relation. Let me ask you a very mathematical question from this concept, which could be asked anywhere in any exam per se. What is the remainder when 2 to the power 100 is divided by 15? So you think you will use a calculator to figure out, okay, what is 2 to the power 100 and then divide by 15? No, we don't want to do that, right? We want to mentally just do this question. What we know is 2 to the power 1 is equal to 2 mod 15. I'm sure you can realize till the time you have a number which is lesser than the divisor, the number that you're dividing with, then automatically that number becomes the remainder, right? So 2 is of course smaller than 15. So 2, when I divide 2 by 15, 2 is the remainder. Now similarly, 2 to the power 2 is congruent to, not equal to, congruent to 4 mod 15, because again 4 is lesser than 15. So now 2 to the power 3 is congruent to 8 mod 15, because again 8 is smaller than 15. But now you have 2 to the power 4. What is the remainder left when you will divide 2 to the power 4, which is 16? 16 divided by 15 will give you remainder 1. So it's going to be called congruent to 1 mod 15. Okay, we are looking at 2 to the power 100. Now 2 to the power 100 is basically 2 to the power 4 whole to the power 25, which will again be congruent to 1 mod 15. Think logically. 2 to the power 4, that is 16. When you divide that by 15, you are getting remainder 1. And hence, when you will be taking a power 25 of that, again, the remainder that you will get when you divide by 15 will be just 1. This is going to happen because 2 to the power 4 to the power 25 minus 1 will be divisible by 15. Hence, 2 to the power 100, when divided by 15, will give you remainder 1.